Hello again, my Algebra 2 friends. So this is a lesson. It is the basis of a lot of our algebra lives so far, and then it'll continue to be the basis for this first semester. We're going to be solving linear equations. So we had been working with algebraic expressions. This is different because we're going to be finding solutions for x or whatever the variable is. And the steps are what you've always dealt with equation solving. You're trying to isolate or get the variable by itself. So let's start off real basic. Nice review for us. We're trying to solve. So we're going to try to isolate the x. What we find is that a lot of kids very much have sloppy work, and I'll be readily admittable that I too am a little sloppy when it comes to my work. So we're all rusty. Now is not a time to get sloppy. Let's look at a line tool here. Here's what I'm going to do. I'm going to draw a line, and it's going to magically make itself kind of straight. That's the equation breaking point. So it's the equal symbol. Left side and right side are separated now. If you want to move across the equation line, you have to do opposites. So here, instead of adding 7 in order to move it or cancel it out, you'd have to subtract 7. So we would do that from both sides. And that now gives us a 4x. These are canceling out, and then it equals a 20. And then here we're trying to solve for x, remember. Right now it's being multiplied by a 4, so we're going to divide by a 4. And I'm showing all my work on each side of the equation. When you start to get a little sloppy in your work and you leave off some of those steps, it's going to come back. And you're going to have some problems later on when we do some complicated things in Algebra 2. So again, I'm going to continue using these lines. Draw a line through my work. It's kind of straight. So we're going to, instead of adding 1, we're going to move to the other side. So instead of subtracting 1, we are going to add 1. So we have this fraction coefficient of 5/2. Don't bother changing that to a decimal. And then we also try not to grab our calculator because there will be a big portion of our SAT that is calculator free, so we want to prepare for that. The best way to remove a fractional or rational coefficient is to multiply by the reciprocal instead of dividing the fraction over. Remember from like 4th, 5th grade, when you divide by a fraction, you really are multiplying by the reciprocal. So let's take care of that. Let's multiply by, instead of 5 over 2, let's multiply by 2 over 5. Over here on the left side, 2 over 5, 5 over 2 will cancel each other, and you'll just have an x. And then over on the right side, if you were, feeling a little rusty and stumped, because maybe you're doing this lesson in August and you're just not feeling it, you could go ahead and type that on the calculator. But those of us who are trying to remember how fractions work, this is like 40 over 5, better known as an 8. It's a multiplication problem, right? Don't worry, we'll talk about fractions a lot more later on in this course. So now we're going to have more complicated questions where you have variables on both sides. You have to kind of make a commitment. Do I want to bring the variables to the left side or the right side? And I was brought up like, you always bring the variables to the left side. And we know it really doesn't matter. So what I found from most kids in the past 15 years I've been teaching is that they tend to bring variables to the side that would create a positive coefficient for that variable. Or in other words, to the side where there's more of that variable. So like right here, for instance, there's 3 a's on the left side and 9 a's on the right side. So they're going to bring the a's over to the right side, meaning they are going to subtract 3a. Now, because we're big Algebra 2 kids, we don't have to do like one step at a time on our line. We can do multiple steps. So if I'm bringing the a's over to the right side, then how about I bring the constants over to the left side all at the same time? So this constant of -8, we could add that over to the left side. I feel like I just misspoke some directional things. Those of you who are new to Mrs. Abruzzo, I'm super dyslexic, so I often mess things up, and it's part of my whimsy, okay? All right, let's look at some things that are canceling. Noticing that things are canceling that I want to cancel. I think that's an important part of algebra, is I intended things to cancel. Did they actually cancel? So easy to screw things up. Usually when I say that, I screw things up. All right, so 13 plus 8 is 21. And then 9a minus 3a is 6a. So last step here, we're going to divide both sides by 6. And then Algebra 2, we're really big on writing our answers as reduced improper fractions. So you could math enter this on your calculator, if you're just feeling very techy today and not very mental mathy. But 21 and 6 can both be reduced by a factor of 3. So this and this cut by a 3 would be a 7 over 2. equals A. Now, if you cranked that in the calculator and wrote 3.5, which is the decimal equivalent, you're right. 3.5 is an exact decimal and very much equivalent to 21 over 6 and 7 over 2. I wouldn't like 21 over 6 because it's not reduced. 3.5 is okay, but I can almost guarantee you that on a test, the directions will be very explicit, like leave your answer as an improper fraction if necessary. So make sure you read those instructions. Now, on number 4, you're going to see what's called the distributive property. We have, oh, I should draw my line in like I keep saying I'm gonna. Line. There we go. Okay, let's distribute that 4 into his parenthesis set. And I notice later on in the equation there's another set of distribution that 10 gets distributed into his parenthesis set. However, it does not get distributed to the 7x, so don't go that far. All right, new equation. Now we got a 12x plus a 4. Drop the equal sign down, and then you have a 10x plus a 40, and then a minus 7x. So there's a lot of next steps you could do, right? So we try to think about things that are effective for us as Algebra 2 learners. There's a lot going on the right-hand side of the equation. I feel like if we could collect some like terms and make it look a little simpler, we'd have less to look at. So, for instance, because they're on the same side of the equation, we're going to smush, just like our last lesson, smush together the 10x and the minus 7x, and that becomes a 3x plus 40. So it's just a simpler, prettier looking version of the equation. 12x plus 4, haven't done anything there. All right, now I'm going to start moving things across the equation line. So I'm going to bring every variable to the left side, because the 12x will be bigger than the 3x, right? So I'm going to subtract 3x over here, which means my constants are going to go to the right side, so I'm going to subtract the 4 over here. And I like when I show that things are canceling. If you don't like crossing them off because it makes you nervous, that's fine. At least acknowledge that they're going to cancel, right? So these are going to be gone, and these are going to be gone. And that leaves us with kick in brain. Here we go. 9x equals 36. And then final step, we're going to divide both sides by 9. That division step, it's not really probably caused you any trouble yet in this lesson. But a lot of kids don't show that division step. And we'll see some questions eventually where if you don't show that division step, you got a lot of problems with executing the right answer. And we'll hopefully run into that today. All right, next, let's talk about just a basic old proportion. You saw a lot of these in geometry. A proportion is when one rational expression equals another rational expression. So a fraction equals a fraction. There shouldn't be anything else. It shouldn't be like a fraction plus a number or a fraction minus something. If you're going to use what's called cross multiplication, I think probably some elementary teacher of yours called them the butterfly method or something horrible like that. This is what you want to use them on, as a proportion. So you cross multiply the 7. What's really happening though, guys, and we'll talk about this more later in the class, is you're multiplying by 7 on both sides. So that's where you're getting this 7x, 7 times x. Put down an equal sign. On the other side of the equation, you would have multiplied by 10. So over here, it would have been, where's my color? Here you go. 10 times 3, so 30. And then you end up with this like linear equation that we're used to solving, right? So we're going to divide both sides by 7. And 30 over 7 does not reduce at all. So we're just going to leave our answer as 30 over 7. If you're not sure if something reduces, you can always do that math or enter thing on your calculator. That works great. All right, same idea here. We got a little more algebra happening on this question because whoa, that's ugly. Okay, you got a 4 times the x minus 3, which indicates we need to distribute that. Now, for me, I'm recording this in June. My brain is like still on vacation. And I'm going to mess up if I do that in my head right now. I'm known to do it, right? So rather than distributing on my first step, I'm going to set it up so I can distribute on my next step. Speaking of distributing, here we go. So we're going to distribute the 4 and distribute the 6. If you've already done so, good on you. All right, so we got a 4x minus a 12 equals a 6x plus 12. Ooh, weird, huh? You don't like when they match like that. It's okay. All right. Finally, we have an equation like we've been talking about today. So we're going to bring all of the x's to one side. Because there's more x's on the right-hand side, I'm going to go that way. So I'm going to subtract the 4x over to the right-hand side. And at the same time, I'm going to move this 12 over to the left-hand side. At first I thought we were going to get a 0, but look carefully, Mrs. Abruzzo. So yes, these cancel. And these cancel. These do not cancel. I got a little confused for a minute. All right, so that's negative 24 equals 2x. And then one more step, we're going to divide both sides by 2. And that answer comes out pretty nice, right? Negative 12. I don't know why I'm writing off to the side like that. That's weird. I should fix that. Okay. So, no, this is definitely not the first time you guys have seen equation solving. We just got to make sure that as we progress through Algebra 2 and it starts to get harder, that these basic elements to algebra, like we're really, really good at. And we have good habits and showing your work. And you notice I use a lot of colors. I'm sure you've noticed that by now. I want you guys to use colors. I think colors are great in math. So I'm going to harp about that a lot. All right, so here, a lot of kids think this is a proportion. But remember, by definition, a proportion is a fraction equals a fraction. So this is like a fraction plus a number equals technically a fraction. So you wouldn't be able to cross multiply the way it looks right now. However, if you would just make one little move, what if you subtracted the 4 over? Then you could interpret this as a proportion. So you've got negative 2x plus 10 over negative 5, which is most definitely a fraction, equals 9. Now, 9 is a fraction, right? It's 9 over 1. So those of you who are big fans of the act of cross multiplying, you recognize that you are going to do this. And then we feel kind of silly doing this now, because what I just did is I multiplied by a 1, which doesn't do anything. So I'm just going to write down negative 2x plus 10 equals, and then over here, I would have multiplied both sides by that negative 5, which is the same thing as this cross multiplication idea. So negative 5 times 9 is where you get the negative 45. And now we have our equation. And my equation line wasn't long enough. Okay. So, that was handy, right? There's only one x in the problem, and it's already on the left-hand side, so let's keep it there. And let's subtract this 10 over. And this is usually where you guys start cursing me because I didn't give you enough room, right? Is that the problem? I didn't give you enough room on the worksheet? Sorry. All right, so if we divide both sides by negative 2. Oops, that's a negative. Now 55 over 2, that doesn't cancel in any way because you have an odd number divided by 2, which would never cancel, or reduce, I should say. But the negative over negative, that does have some simplification. That becomes a positive. So x equals, and then we would just leave it as 55 over 2. Remember, math enter on your calculator. It's your new best friend. All right, so those are a little reminder about how we solve proportions. Wouldn't it be nice if everything was a proportion? They're not. Okay, so the next set of questions coming up are a little weird. They're going to have a whole bunch of fractions, and we wouldn't, without doing a lot of work, we wouldn't be able to create proportions. So we're going to use an idea called the least common multiple. Before we get to the algebra part of using the least common multiple, let's talk about what a least common multiple really is. So a least common multiple would be, okay, if you started writing out your multiples of each number, right? So like 4 as compared to 5. And there's a couple different ways we can find least common multiples, guys, and I'll show you this one for now. So 4, his multiples, and not his factors, but his multiples. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on and so on. So what do we have here? 4, 8, 12, 16, 20, 24, and I could keep writing forever. I'm going to stop writing for now. Hopefully this is enough. And now we're going to start writing the multiples of 5 out. So 5 times 1, 2, 3, 4, 5, and I should stop writing because what you're going to do now is look at the first number that they have in common, right? Common. And least meaning the smallest. So the first one that they have in common, it would be the number 20. Now some of you, as soon as you saw this problem, you're like, it's 20. Great! You have really wonderful number sense. I think that's fabulous. Some of you go, this reminds me of that stuff we did in 5th grade with the common denominators. Bingo, this is exactly what you did with the common denominators business. And some of you are going, can I just multiply 4 times 5? Yes! However, when you multiply the numbers together, what you are getting is called a common multiple, not necessarily the least common multiple. Here's the good news today. It doesn't matter. So in this case, 5 times 4 was 20, which happens to be the least common multiple. But let's use that little trick on 2, 3, and 4. 2 times 3 is 6, and then times 4 would be 24. So someone in your class could propose, I think 24 is the least common multiple. And your teacher would say, great idea. What you found was a common multiple, but I think we can go lower. I think there's a smaller number that they have in common besides 24. So let's look at that. And I know some of you are like, I already know it. Why is she going through all this? Because maybe one day you'll have a set of numbers that you have no idea what the least common multiple is. All right. 2, 4, 6, 8, 10, 12, 14, 16. I'm going to stop writing. Okay. 3 would be 3, 6, 9, 12, 15. I'm going to stop writing. And then 4 would be 4, 8, 12, 16. I'm going to stop writing. So this is where kids get into trouble because they're like, oh, 6. They had 6 in common. Well, the first 2 had 6 in common, but not the third numbers. 4 didn't have a multiple in it that would work for 6. Or 6 wasn't a multiple of 4. So keep looking, keep looking. Ah, there he is. There's the first number they have in common. So for us, the least common multiple of 2 and 3 and 4 would be the number 12. But if you were like, you know what, I went with 24 and my work ended up beautiful. Well, for what we're about to use it for, you're right, it will end up beautiful. So that's the good news. There's also a way on your calculator, and you might want to write this down in your notes, that you can find the least common multiple of 2 numbers. It'll only work for 2 numbers. So if you go to math, press the math key. We'll do this a lot in class. And then you go over in that menu to where it says NUM, which is the numerical sub-menu, and then down to number 8. And it'll see LCM. You can type in 2 numbers at a time. So like what we could have done was like LCM of 2 and 3, and that would be a 6. And then you could have done LCM of 6 and the third number, which is 4. And then it would have given you a 12. Now, I used to be a teenager. I know what you're thinking. That seemed like a lot of work. Yeah, I'm with you. So if you don't like that calculator usage because it feels like extra steps and work, I understand. All right, so look at number 8. This is our last type of equation we're going to be solving. And I cannot rewrite this right now easily as a proportion unless I want to deal with fractions. And I'm going to be honest, guys, I really don't. I don't like fractions. I never have. I think it was 5th grade that ruined them for me. So what if we got rid of them? So we have an equation. You can do anything you want to an equation as long as you do it to both sides. So what I'd like you to do first is find the LCM of the denominators. So the LCM of 6 and 12. Well, again, you can use your calculator like I just showed you, or you could think really hard, or you could list out all the multiples. But wouldn't it just be 12? Thinking it would just be 12. Yeah, that would be the first number they have in common. So big parentheses around the whole problem. And I want you to take the number 12, and I want you to write it out in front, which I don't know about you, but gut instinct tells me if there's a number out in front of parentheses, what I'm supposed to do is I'm supposed to distribute it. All right, so here's what's going to happen. Because we've used an LCM of the denominators, all the denominators will end up reducing and eventually canceling, creating a new equation that is equivalent to the original equation. But there won't be any fractions anymore, which makes me very happy because I don't like fractions. So right here, we've got a 12x. Now, if you're not real handy with fractions and reductions and whatever these look like to you, you can type it on your calculator. You can say 12 times 5 over 6 on your calculator. Those of you who love to do mental math in your head, A fraction is really a division and a multiplication problem all in one, right? So you can either take 12 and multiply by 5, then divide by 6. That seems hard. Or you could have taken 12 divided by the 6 first, and then multiplied that by a 5. So if you're using mental math, it'd be quicker if you do the division first. So 12 divided by the 6 would be a 2. And then 2 times the 5 that's up top would make that a 10. Again, no shame in grabbing your calculator right now, guys. I don't want you to freak out over the fraction reduction. If that's really important to you as a human that you remember how to do that, come see me. We will work on it. All right, 12 times 1 over 12. Again, the denominator is the division part. So 12 divided by 12 is 1. 1 times 1 is 1. And looky there, you got no more fractions. So now we just have a real basic two-step equation trying to solve this. That's supposed to be a straight line. I'm going to add the 10 because there's only one x in the problem. I'm going to keep it where it's at. So we have 12x equals 11. And then we're going to divide both sides by 12. And notice, my friends who don't like to show that division step, they're going to give me all sorts of weird answers at times. Showing that division step doesn't allow you to make what I call a dyslexic mistake. So the kid who says it's 12 over 11, just because that's the way their brain rearranged it, that's a very common mistake. So show that division step. Very important. All right, one more big guy here. Oh, boy. Well, I definitely want to get rid of all those fractions. Now, something to note, there's what's called a constant in this problem, and it is technically a fraction, right? It's 2 over 1, so there is a denominator of 1 there. So what I'm looking for would be an LCM of 2 and 4 and 5 and 1. Now, 1 doesn't do anything. I'm not going to write it down. You cannot type it on your calculator this way because it only does 2 at a time, so you'd have to do 2 steps. That seems like a lot of work. And then some of my friends are like, hey, I'm just going to multiply 2 times 4 times 5. Well, 2 times 4 times 5 would be 8 times 5. That would be 40, right? 40 would work. But I think there's a smaller number, something they have in common before 40. And I think it's 20. Now, my friends who are going to use 40, totally fine. You're going to end up with a different looking equation, but your final answer will reduce to the same answer. So you did nothing wrong. You're just going to have higher numbers to work with. And if you didn't have a calculator, that kind of mental math is difficult. If you have a calculator, then whatever. Who cares? Do whatever you want. Your calculator is going to reduce it for you. All right. Do not forget to distribute the 20 to this 2. It's not going to divide by anything, but it does have to multiply by 2 over here, or negative 2. All right, here we go. Distribute time. Again, calculator usage here is totally fine. 20 times 3 over 4. If you just type that in, you'll get the right answer for this first term. My friends who are doing mental math, you're going to divide by 4 before you multiply by 3. So 20 divided by 4 is 5. 5 times 3 is 15. So that's a 15x. 20 times 2, that's now a negative 40, or a minus 40. All right, 20, divide first, so that'd be a 10 times 5 is a 50x. And then 20 divided by 5 is 4. 4 times 1 is 4. Okay, it's equation solving time. Let's start moving all of our variables to one side. Knowing how students have been working the last few years, they like when the variables stay positive. So that tells me you're going to subtract the 15x. If you didn't go that way, it's fine. You'll end up in the right place eventually. So if you're bringing variables to the right, I said left, didn't I? If you're bringing variables to the right, constants to the left. I told you, dyslexic. It's a thing. All right, definitely should see some cancellation here. Yeah, good. So we have negative 44 equals 35x. This is a good case of the dyslexic math student right here. You're dividing both sides by 35. You're trying to isolate for x. This does not reduce in any way. The negative doesn't cancel out. So I'm going to leave my answer as negative 44 over 35. If you flip that equation solution around and you said x equals like a normal human, I love that too. I just didn't want to confuse anybody who's looking at my slides. All right, so that was about as tough as the equation solving we'll get for this first lesson. We do have to talk about applications of linear equations. Remember earlier in the unit we talked about algebraic word problems and setting up and writing verbal models, and that would still be a really useful skill to set these equations up. This is really a nod to the SAT questions that you're going to encounter. So SAT really likes to give you like a whole paragraph of life, and then they want you to somehow throw it into an algebra sentence and possibly solve it. And if you can muscle through like, okay, what are my variables and what's my verbal model, it really helps things kind of align. The questions I have for you today aren't really that hard. So we have a real estate broker who has a base salary of $18,000. So they get that no matter what for the year. And then a 4% commission on all of the sales that she does for the year. So she's got her eye on $55,000. She needs to make at least $55,000 this year. So she's just curious, like, how much do I really have to sell, right? And, you know, I am not a real estate broker, but they're selling real estate, right? Like homes and businesses. So if you think about like how many homes a real estate broker has to handle during the year, I'm thinking a few. And homes are, you know, for numbers' sake, let's talk like $100,000. So this number that we're finding should be several hundreds of thousands of dollars. So her base salary is $18,000. And then 4%, remember percent is out of 100. So you can either type 4 out of 100 or remember to move the decimal point over two times. So that's 0.04, but it's times whatever she's selling, and we don't know that. So in math, we call that a variable. And we want her total salary to equal $55,000. All right, we got our stuff set up. And like I said, I should have gone through and found, you know, a verbal model and all that good stuff, but time's wasting away here. All right, we got to subtract 18,000 because she's going to make that no matter what. It's kind of nice. What do you think happens if you're like a dud and you don't sell anything? I wonder if I don't know. All right, so $37,000 is what she has to like earn from her sales. So if we divide that by 0.04, I don't know. I'm going to try this one out. Okay, so I just got an answer that I think makes sense. She's got to sell like $925,000 worth of real estate this year, or at least broker the deals. That makes sense. I mean, that's like 10, properties over the course of a year, so almost one a month. That seems like a reasonable answer. If I did all this work and I got something really crazy, like I get a lot of kids who multiply by 0.04, which is not that answer. It's much smaller. It's $1,480. So does that make any sense? All year long, all she did was sell a house worth $1,500. Like, no. And I know none of you own houses, so you don't really know what this means. But I think you know a house does not cost $1,500, right? So use your logic when you're answering these questions as well. There is one more question. This one might be more up your alley. It's talking about summer pay. So you've got a job that pays, $5.60 an hour. They hate you or something? All right, but if you work overtime, you get $8.40 an hour. That's not even minimum wage anymore. All right. So how many hours of overtime do you have to work in order to earn 287? So this $5.60 an hour, assuming that you even get to the overtime step, that means you worked all for 40 full hours. So this $5.60 times 40, that was like your quote regular pay. And then you have this $8.40 times some mystery number of overtime hours. And you need $287. It's a very specific amount. All right. So this number, I think we can calculate that. This is where usually I'd wait for y'all to type it in class, but I don't have any kids with me today, so here I are. $224 from your regular work. So let's subtract that away from the total pay. So I still got to make up $63, or you do, I guess. So if you take that $63 and you divide by 8.4, $8.40 per hour. I feel like I calculated something goofy. Oh no, this is the right answer. I get 7.5 hours. So, child, you're going to need, first of all, I think you need a better job. This is a horrible job if that's all you get paid, right? Just saying. And you're going to have to work 7.5 hours of overtime during your summer. Good luck. All right, so I'm positive I gave you gobs of things to practice. You really do want to practice this. I know some of you are looking at this lesson going, it was easy. I'm fine. I don't need to do it. You do. You need to get back in the swing of things. It's been a few months off, and this will be a nice lesson for you to get your, dip your toes back into the algebra pool, right? All right, good luck, everybody.